the one kind of cluster. And why do we need a cluster? Because when we do our research, we maybe will put lots of data into cluster, into the computer to help us to deal with the data. But if today we put our data into a normal PC, maybe we will spend lots of time waiting for the results. So we use this kind of computer to help us to do our research. There are lots of merits about cluster. In fact, there are some drawbacks behind it. Why? Because the required computer number in cluster vary with time. I will make an easy example. First, we assume every user can only use one computer. And then, today, we have 100 computers. We have 100 users to use the computer. So, we turn out 100 computers for them to use. But maybe several hours later, or several days later, the number of users reduced. We assume only 10 people use the computers. But all the computers still pop up. I think this problem, our problem appear because we only need 10 computers, but other 90 computers still pop up. That means it's waste electricity and it will waste money. Maybe we will think it's not a very serious problem, so I will help us. So we begin to do a simple calculation to calculate how much we will spend on this consumption of our electricity. In Wittiera, the idle cluster consumes 12,342 kilowatts. And we will calculate how much kilowatt hour we will spend for 1 year. So we'll multiply this value with 24 hours. And in a year we have 365 days. So we'll multiply this value. So we can get this answer. And in Taiwan, for each kilowatt hour is about $3.480. So every year, we maybe will spend about 367,894. In US dollar, it's about 12,000. It's very much.
Sorry for interruption. Is that only idle part? So the power, kilowatt?
Oh, yes. You
don't count the running.
This unit is mean how much energy we produce per second. But today, we are not calculate how much energy we spend.
Yeah, but is it total or just idle part?
Idle part. Yes.
Question. Are you counting the energy spent in cooling the system?
No, nine. Okay.
So that's the reason why I need to develop this system. Okay, now let's talk about in Wittiera, the current cluster situation. We assume in our cluster there are only 6 computers we can use. And maybe today there are 4 people to use this computer. But all the computers still pop up. And later on, maybe 3 people, and later on 2 people, 1 people, and 0 people. We find the problem. No matter how many people use the cluster, all the computers still pop up. So it's a waste of energy. So let's talk about the desired cluster situation. Today, there are 4 people to use this cluster. The server detects this situation, so he thinks there are so much computers power out, so I think I need to turn off 1 computer, so it will computers, and this idle computer will not be turned off. It will be regarded it will be left as spare computers. And later on, there are only one people use the computer. The server will detect this change, so the server will decide turn off other computers. There's only one idle computer left. This situation is decided, so that's my goal to develop this system. Now, let me talk about my system structure. In Tiara, we have about more than 100 computers, but we often divide them into parts. One is server computer, and the other is client computer. You can see the server computer is the king of the cluster. It can control all the computers in the cluster. And what is client computer? You can think, you can regard it as a slave. It will be used by the user. Now, I will talk more detailed information. In the computer, in server computer, there are 4 functions. And in the client computer, there are 3 functions. What's a function? You can imagine. Function is a person live in the computer. It's a worker. And in server computer, there are 4 persons. They are working periodically and independently. And in client computer, there are 3 functions. There are 3 persons are working right now. Now, let's talk about the register. When we turn on a client's computer, this client computer will tell the server computer, you can control me. I'm the member of your cluster you control. What's the meaning of the register? You can imagine the server computer is the teacher, and the client computer is a student, a newcomer student. If today the newcomer student wants to attend the class, she have to tell the teacher beforehand, to tell the teacher that I want to attend your class. Now, let's talk about data. When the server makes any decision, the server needs to know the current condition, so the server needs to take data. First, if the server computer needs to know this client computer, needs to know the current condition about this client computer, it will send the request to the client computer. And then, after client computer receive this message, it will accept and send information to the server. What kind of information will be sent? Like IP address, MAC address, and the idle time. And then, after server gets the information, it will automatically store this information into the database. Why do we need a database? Because later on, we will make a decision, we will analyze this data, so we need a space to store this data. Make an easy comparison again. You can, server computer teacher, the teacher will tell the student, hi student, you have to hand in your homework. Then, after the student gets this message, it will hand their homework to the teacher. Now, I will talk about the shutdown function. First, the shutdown function will take data from the database, and then this function will analyze. Does current condition match shutdown logic? If it matches the shutdown logic, it will decide which computer need to be turned off. Maybe this one will turn off this computer. Now, let's talk more detailed information about the shutdown logic. First, this function will make a shutdown list. The client computers of which idle time was more than 1 day will be in this list. Take an example. Today, in our cluster, maybe we have 3 idle computers, but maybe only one of them, the idle time is more than 24 hours. this computer will be appear on the list. The cast load need to be kept at 80% as soon as possible. What's cast load? It's the ratio of used computers to all turn-on computers. Take an example. If today I turn on 100 computers and 50 of computers was used, so our cast load is 50%. And if the cast load is below 70%, the system need to turn off the client computer which appear on the shutdown list. However, we have a limit. No matter how low the cast load is, at least 33% of the reduced computer need to be powered up. I'll make an example. If today, in the cluster, we register about 100 computers, but we power up 33 computers, but only one computer was used. So the cast load is very low, it's about 3%. So do I need to turn off the computer? The answer is no. Because if I turn off one computer, it will be below 33%. Now, I will talk about the turn on decide list function. In the same way, this function will take data from the database and then analyze this data. Does the current condition match the turn on logic? If it matches, it will calculate how many computers do I need to turn on and do that. Maybe turn on 1, turn on 2. Now I will talk about the turn on logic. If the cast load exceeds 80%, the system need to start the following procedure. So if it's below 80%, it will not do anything. Here's an order. And the server need to check whether they are waiting work in current system and decide how many nodes need to be turned on. For example, today maybe someone put some job into a computer, and the current system know this computer maybe need 20 computers to do this job. So if these jobs are waiting, so this system will turn on other 20 computers for user to use. And I'll talk about my result. In this cluster, there are about 28 computers, and half of them, 14 computers was used right now. So I will check. I will enter into the server to check whether all of them was registered in the server computers. I find BC1, BC2, BC3, and all of them. And it will get the MAC address of the client computer and the IP address and their current condition. They are turned on. If they are turned off, its status will be turned off. Okay. Now, in the server computer, I execute this function. Because the turn decide function we do it, and it starts to do the shutdown decide function. If there are 26 registered computers, and all of them power up, and 12 of them is idle. 14 of them are used right now. But so it's about 53%. So it need to turn off the computer. But how many computers I can turn off? It's only one. So it starts to turn off computer. It's turn off the BC17. And then it's following to following job. It start to turn off BC18 and BC19. And the BC20 and the BC21. BC20 was about 73%, so it will not shut down any computer later on. Now, let's check whether this the system turns off all the computers. In this terminal, before this terminal do this message, it connects to the BT17. But the message said it was turned off, and BT18, BT19, and the BT21, and BT20, 23, 22. I will talk about my future work. Make both of the turn on logic and the shut down logic configurable, because all my logic stay in the programming code. If I want to change the code, if I want to change the logic, I have to enter into the software to change the code. It's very troublesome, so I think there are some improvement to do.